Hello and welcome to this new video. We're going to talk about the variance and standard deviation. The variance and the standard deviation is not measure of essential tendency, it's a measure of dispersion. That means if we have a set of the values, quantitative values, and we want to know how the values is dispersed or far away from the median or close to the median. For example, the median the mean doesn't reflect how the data is distributed. For example, if we have a mean of the same mean 13, for example, 13, and the other mean is the same 13, but we have values like for example, we have two values for 14 and 12 divided by 2, it gives us 13. For example, if we have 16 and 10, it will give us 13, but the dispersion here is far greater than the dispersion here. This is why we call the characteristics of dispersion for the variance and the standard deviation. Okay, we're gonna talk about the formula for it, how we're gonna calculate the variance and standard deviation. Okay, here we have the monthly salary in $1,000. For example, the number 22 employees have salary between 8K and 10K. Okay, etc. etc. Here we have continuous variables. In order for us to calculate the variance, the formula for it is right here. Let's call it the variance. Variance equal to the sum of number of it, N-E, and I, multiply by X, E, which is the character we quantify, minus the average, we call it X bar, all of that in square, divided by sigma, which is the sum of N, E. This is the variance. The standard deviation is the square root of the variance, simply the square root of the variance, which is here. We elevate all of that in the square. The same here. Divided by. Okay. So I'm gonna explain to you how this we're gonna calculate in Excel file. Here we have the monthly salary. Okay. Here we have the number. The first thing we're gonna do is we want to quantify the value to quantify the character. The character. To quantify the character we quantify, which is we quantify the character, which is the monthly salary. We took the mean, the average of monthly salary, because here we have continuous variables. It's 8K and 10K. The average for it is 9K. Here 10 and 12 is 11K. 12 and 14, 13K, etc. Now what we're gonna search for is the average salary. Okay, the average salary. If we want to calculate the average salary, we look for the average of the character we quantify, multiply by the number, which is N-E, Ni multiplied by Xi. 9 multiplied by 22 is 198. 11 multiplied by 28 is 38. And then we look for the sum of it. Okay, that means the sum of it, which is sigma of ni xi. If we want the average, we divide by the number, which is 100. Okay, I'm gonna show you the formula for it, which is, that means we look for the average x bar, which is x bar is ni divided by sigma of ni. That means we have the sigma, we calculate them, we calculate the sum of it, which is 1206. It's 1206 divided by sigma of ni, it's 100. It will give us directly 12.606. That means the average salary of employees in this company, it's 12,060 $60, which is approximately 12k, approximately 12k. It's 12,060k. Okay, 12,060k. I'm gonna explain the average, which is x bar 12.06. Okay, then we're gonna calculate according to the formula, which is xe more x bar. I'm gonna calculate every column. I'm gonna calculate the operation, the mathematical operation for it. Then we will look for the sum of ne multiplied by xi minus x bar, and elevated to square. Okay, xi minus x bar, which is this one. 9 minus 12.06 is minus 3.06. 11 minus 12.06 is minus 1.06. 13 minus 12.06 is 0.924, etc. Then we're gonna elevate all of that to a square. Okay, it's 9.36. 9.36 the elevation of square of minus 1.06 is 1.12. 0.94 is 0.66. 2.94 is 8.64. 4.94 is 24.4. Okay. Then we're gonna calculate the we're gonna take that, multiply by the number. Okay, 9.36 multiply by the number, which is 209.92. 1.12 multiplied by 28 is 31.36. 0.88 multiplied by 30 is 26.4, etc. Then we look for the sum, because we have the formula is sum the ni multiplied by xi minus x bar in the square, which is 515.28. Then all of that divided by sigma of ni, which is 100. Okay. That means we calculate the division of it is 1528. That means the variance we have is 5.1528. Okay. And that means if we want, this is the variance. If we want to calculate the standard deviation, is the square root of the variance, which is simply here we have 5.1528, 1528. The square root of it, the square root, this is the variance. The square root is division of it, 5.1528. It will give us if we calculate square root here, we're going to calculate square root. Which is 2.20 approximately 27. 2.27. Which is that means we don't have a lot of dispersion in this dispersion between employees in terms of salary. We have because we have a standard deviation close to 0, which is we don't have lots of dispersion. Okay. So that's it for this video. But I'm gonna apply this the Excel formulas give us opportunity to calculate directly the variance and standard deviation. We're gonna look for that in our data sets of medical blood pressure data sets. Okay, I'm gonna call for let's calculate the characteristic of dispersion, variance and standard deviation. Okay, then we call for the formula of variance. It's 83.37. It's 83.36. We're gonna generalize. Here is 240.59. Here we have 170.5. Here we have 12.52. Here we have 1018.46. We call for the standard deviation is simply the square root. Then we're gonna calculate the square root of variance of the age 83.36. It's 9. We can take only two numbers after the point. Generate that 14.33, 10.84, 3.45, 3.54, and 31.91 is the standard deviation of cholesterol levels. So that's it for this video. I hope you learn to easily calculate the variance and standard deviation. I'm gonna upload this file right here for you. I'm gonna upload this file right here. I'm gonna upload it to you so you can easily learn how to calculate the variance and standard deviation. Okay, So that's it for the video. The next video we're gonna talk about is the Lorentz curve and GNI index to know how to know the equal distribution and unequal distribution, for example, of salary, of income, etc. It's also related to descriptive statistics, Lorentz curve, the concepts of Lorentz curve and GNI index. Thank you.